Welcome to this lecture series on Environment and Ecology presented by Mentors for IAS in association with Bangalore IAS Academy and Namak APSC. So this video is in continuation of the last video. So in this particular video as well, we will be considering certain terms and concepts which are important to be understood in the beginning itself before we move on further with environment and ecology. So the first term that we'll be dealing with today is an ecotone. Now, very simple. An ecotone is nothing but a zone of junction, or it is a zone of transition between two different biomes or between two different diverse ecosystems. Very simple. Say for example, in order for the sake of understanding, take two terrestrial ecosystems. Take a forest and then take a desert. Now, where does a forest end and where does the desert begin? The thing is that there is no abrupt end or a boundary line between this forest and a desert. But this forest will gradually make a transition into a desert through a transition zone, where this transition zone will be a grassland, and we'll call this grassland as an ecotone. So once again, I'm going to repeat myself. Whenever you have two different ecosystems, one ecosystem will make a transition into the other ecosystem, and this transition zone in itself may be another ecosystem, and we'll call this transition zone as an ecotone over here. So similarly, we can have several other ecotones. Take for example a marine ecosystem and a terrestrial ecosystem. When a marine ecosystem makes a transition into a terrestrial ecosystem, as is shown in this particular diagram over here, whenever you have this, you have another ecosystem that is a transition zone or the ecotone, which we refer to as a mangrove, or we may have a marshland. Similarly, we may have an estuary. An estuary is also an ecotone itself. That is where fresh water meets saline water, or I can say that the river meets the sea. Similarly, we can have a coastal zone. A coastal zone is also an ecotone. This is where the land meets the sea. So I hope this is very clear. Very simple. Ecotone is nothing but a transition zone between one ecosystem into another ecosystem, and this transition zone is referred to as an ecotone. If this is understood, there are certain other characteristic features of an ecotone. Now this is very important. I want you to please pay attention and understand and also remember the different characteristic features of an ecotone. So the first feature of an ecotone is the ecotone may be very narrow or it may be very wide. Now when I say that the ecotone may be narrow or wide, it is with respect to the area or with respect to the size itself. So in the previous image, I showed you this transition zone between a forest and a desert where you have a grassland. Now the extent of the grassland between the forest and the desert may be very large. I also told you that the grassland in itself may be another ecosystem. So if the grassland itself is another ecosystem, you may also have a transition zone between the forest and the grassland. Now, this transition zone between the forest and the grassland will be very narrow. So what I'm trying to say is that if you consider the forest and the desert, the transition zone between the forest and the desert is very wide. But the transition zone between the forest and the grassland itself is very narrow. And therefore, we say the ecotone may be narrow or it may be wide. The second point is, when you have an ecotone, this ecotone will also have conditions which are intermediate to the adjacent ecosystems. Meaning the conditions which are found in the ecotone, they will be very moderate. So if you have a deciduous forest over here, the deciduous forest may have more rainfall, it may have heavy rainfall when compared to your grasslands. Where in the grasslands, you'll have very scanty rainfall. So this transition zone between the deciduous forest and the grassland, in that region you'll have moderate rainfall, you might have moderate temperature, the climate will be moderate. So it will be between the two extremities of the either adjoining ecosystems, and therefore we say the conditions which are found in the transition zone will always be intermediate to the adjacent or adjoining ecosystems, and therefore they are always moderate. Now since you have intermediate conditions between the two ecosystems or the adjoining ecosystems within the transition zone, this ecotone is a region where the two ecological systems are going to meet, are going to mingle, and also sometimes may form a new community itself. Therefore, this is very important. Please remember, the ecotone is always a zone of tension. Why is it a zone of tension? Because it is a region, it is a zone where two ecological systems are going to meet, it is going to mingle, resulting in the formation of a new community. Therefore, the ecotone is a zone of tension. The next point is that when you have a very well developed ecotone, this ecotone may have organisms which are not found in the adjoining communities. Meaning, you may have, say for example, if you take the forest may have tigers. If you take grasslands, the grasslands may have rabbits. Then within the ecotone, you may have deers which are not found in the forest, neither in the grasslands. It's just an example. What I'm trying to say is that a well-developed ecotone can have organisms which are not found in the adjoining ecosystems or communities. The next point is an ecotone will always show a linear progression. An ecotone will always show a linear progression, meaning the number of animals or a certain species, as we move on from one ecosystem to another ecosystem. If you see this diagram over here, you should be able to see this line. This line represents the population. So as you move from one ecosystem to another ecosystem, the number of species from one ecosystem starts to decrease. At the same time, as you start to move from one ecosystem to another ecosystem, the number of species of some other species will also increase, and therefore we say that an ecotone will show a linear progression, because there is because the number of certain species can increase, whereas some other species also decreases within that ecotone, and this is nothing but a linear progression within the ecotone. Now, there is one other important thing about an ecotone. Since I said that the conditions which are found within the ecotone is intermediate of the two adjoining ecosystem, the ecotone will also show greater productivity and biodiversity. So even though I said that there is linear progression where the number of species may decrease from one ecosystem as we move on to the other ecosystem, and there may be certain other species which will increase in its numbers, but within that ecosystem we may have more species compared to the adjoining ecosystems, because it will have greater productivity, it will also have greater biodiversity, because it acts as an energy net. It is able to capture the energy flow between the two ecosystems. So please remember, an ecotone always, or at least many times, will always show greater productivity. It will also have greater biodiversity between the two ecosystems. So to sum it up, an ecotone is nothing but a border zone where two ecosystems meet and mingle, sometimes forming a new and different community. Okay, so if you have understood an ecotone, this is nothing but a continuation. It is a continuation of the ecotone itself. So when explaining ecotone, I did mention a point. I did say that when you have an ecotone, there may be certain species which are not found in the adjoining ecosystems. And at the same time, you can have a mixture of species which are found in both the ecosystems. So if you take this diagram on the right hand side over here, you should be able to see two ecosystems. You should be able to see ecosystem A, and on the other side you should be able to see ecosystem B. Now the intersection between the ecosystem A and ecosystem B, which is shaded in pink, now this intersection between ecosystem A and ecosystem B is referred to as a ecotone. Obviously that is what we have discussed until now. So this intersection between ecotone A and ecotone B, this intersection is the ecotone. Now If you consider the number of species or the number of animals in ecosystem A and B and then compare it with ecotone, you can see that in ecosystem A you have 3 species. The 3 species are represented by squares, and if you take ecosystem B, you also have 3 species where the 3 species are represented by circles. Now when you take the ecotone itself, now if you see the ecotone, since it is an intersection zone, you do have 3 species which are found in ecosystem A, that is represented by squares. You do have ecosystems represented by circles which are found in ecosystem B, and you also have new species represented by triangles within the ecotone. So I did tell you that the ecotone may have greater biodiversity, it may have greater productivity, and the ecotone, due to its intersection, due to the certain qualities it brings in, it may have species which are not found in the adjoining ecosystems. So I'll just repeat myself over here. Sometimes these species will have a greater population or population density in the ecotone than the ecosystem itself, meaning when a species is found in greater numbers in the ecotone rather than the ecosystem, this is referred to as the edge effect. Please remember, when a species is found in greater numbers in the ecotone rather than the ecosystem itself, then this is referred to as the edge effect. So what I'm trying to say is that maybe in ecosystem A you may have 10 deers, and in the ecosystem B you may have only 5 deers, but within the ecotone you may have 50 deers. So this phenomenon where the ecotone has more deers when compared to ecosystem A and ecosystem B, due to certain qualities it offers, this effect or this phenomenon we'll call it as the edge effect. And such species, in this case the deer, such species, we will refer to such species as the edge species. The best example in real life is nothing but birds. This edge effect and the edge species is especially true for birds, where the birds are found in greater numbers in mangroves, where a mangrove is nothing but an ecotone. It is found between the intersection of a marine ecosystem and a terrestrial ecosystem, where birds are always found in greater numbers between the adjoining ecosystems. So birds represent an edge species where they are found in greater numbers, and the phenomenon is nothing but an edge effect. So the next topic that we'll deal with is ecological niche, or simply a niche. Now, the niche of an organism is the functional role that it plays within an ecosystem, meaning niche refers to the unique functional role and position of a species within its habitat or ecosystem, where this, say for example in this diagram, if you see the mouse over here, the mouse, now the niche for this particular mouse will also depend upon the biotic factors, which represents the living things, and also abiotic factors, which represents the non-living things. So in order for a niche to have been formed for any particular organism over here, it will depend upon the biotic and abiotic factors for a particular species, which is necessary for the species to survive, to stay healthy, and also to reproduce. So in order to make this part more clear, okay, please try and understand what I'm going to say next. If you consider a niche, it is always advantageous for a species to form a niche. Why? Because a species will always consider it more advantageous to occupy a unique niche within an ecosystem to reduce competition for resources. So if you see the diagram in your top right corner, you should be able to see 3 axes. You should be able to see you should be able to see x-axis, y-axis and z-axis, where x-axis represents a range in temperature, y-axis represents the range in altitude, and z-axis represents the range in salinity. Now what happens in the ecosystem is that in order to reduce competition for resources, You may have certain species which will try and adapt to a unique ecosystem, which is unique because you don't have competition. If you don't have competition, the organisms find it easier to access resources for survival, and therefore the probability of survival also increases. It also becomes easier. So what will happen is that some organisms may try to adapt to a unique range of temperature. So this adaptation to a unique range of temperature, that particular ecosystem for that particular, or that particular habitat for that particular organism, becomes its own niche. You may have certain birds which will adapt to a certain altitude in order to reduce competition. Then that particular altitude becomes a niche for the bird. You may have certain other organisms which may adapt to certain salinity range in order to reduce competition. Then that becomes a salinity, and then that becomes a niche for that particular organism. So this adaptation to a particular habitat or to a particular condition in order to reduce competition is seen in many organisms, especially in rainforests, where we should be able to see vertical positioning. See, we always say that when it comes to rainforests show maximum biodiversity. So if you have maximum biodiversity within the rainforest, you'll have maximum competition. Now, if competition is more, species will find it difficult to survive. So therefore, the species within the rainforest will try to adapt to a unique habitat in order to reduce this competition, so that it becomes easier for them to survive. I'm pretty sure everybody knows that in rainforests, the trees grow very tall in order to get more sunlight. So what happens is that these trees will grow very tall, and they use more energy to grow tall, so that they don't have to compete for sunlight. And since they use more energy to grow tall, you might have very small leaves. At the same time, you may have other trees which do not grow very tall. If they don't grow very tall, then they will have to fight more for sunlight for other resources with other plants. You might also have some other plants which have adapted, like say creepers or epiphytes, where they have adapted to a particular habitat in order to reduce competition for resources. So these kind of adaptations which are seen in rainforests are the best example for me to explain what is a niche. So I hope with respect to these examples, the concept of niche is clear. So what happens is, different species may share a habitat, but no two species will share a niche. So I told you, I gave you the example of the rainforest over there. They're sharing the same habitat, but they do not share the same niche. I want you to remember this. This is very important. Different species may share a habitat, but no two species will share a niche. And this is because of the competition with one another until one is displaced. Now, if this is understood, if this concept of ecological niche is understood, it also gives rise to another principle known as the competition exclusion principle. Now, this competition exclusion principle refers to two species competing for a limited resource. So what the competition exclusion principle says is that when you have two species competing for the same limited resource, then the two species will not be able to coexist at the constant population values. So when one species has the slightest advantage over the other, the one with the advantage will try to dominate in the long term. So this leads to the extinction of the weaker competitor, or the weaker species may evolve or change its behavior, or either move on to another ecological niche itself. This is known as resource partitioning, and it helps species to coexist, as there would be less direct competition between them. So even if you've not understood what is this competition exclusion principle, I'll just give you the example with respect to this diagram over here. This principle, the competition exclusion principle, should be very clear to you. So take this example over here and consider this image over here. So in the first image, you should be able to see a yellow bird of smaller species foraging across the entire tree. Sometime later, what happens is, you have another bird, a red bird of larger species, which also starts to forage on the same tree, and now you have competition between the red bird, which is larger in size, and the yellow bird, which is smaller in size. So now you have competition, but the red bird, being of larger size, is able to dominate over the yellow bird, because of which the yellow bird is not able to compete against the red bird, and now you have shortage of resources which are available for the red birds and the yellow birds. So now there is a pressure on the yellow bird to either move away to a new niche, to either evolve or to change its behavior, because it cannot continue to compete with the red bird. So as the red bird starts to dominate in the middle of the tree for the abundant resources, the yellow bird is forced to adapt to a new niche and is restricted to the top or bottom of the tree to avoid competition, or it might relocate to a new tree itself. So this is known as resource partitioning. Now the resources which are available in the tree is partitioned so that you don't have direct competition between the red bird and the yellow bird, and therefore now they are occupying a unique niche. So once again, summing up the entire concept, if the habitat of a species is the address, that is where the species lives, then the niche can be its profession, that is the activities and the responses specific to that species. Hence, the niche of a species will always include all of its interactions with the biotic and the abiotic factors of its environment, and it's always advantageous for a species to occupy a unique niche in an ecosystem, because it reduces the amount of competition for resources that the species will encounter. So even if you, the person watching this video, whether you are a student, a working professional or a housewife, the role that you play forms a part of your niche. Now the reason we have to study and understand a niche is due to its role in conservation of organisms. Now, if we have to conserve species in nature, in its native habitat, we should have knowledge about the niche requirements of the species and should ensure that all requirements of its niche are fulfilled. Say for example, we are fighting for tiger conservation, then it is important that we understand the requirements. It is important that we understand the native habitat or the niche of the tiger. If you are not able to provide for its niche, then our fight for tiger conservation may be futile. So only when we are able to understand the niche of every particular species can we fight for conservation. So I hope you have learned something new today. Thank you very much. For any further information, do contact us, and this video will continue. We'll come up with more videos in order to complete and cover environment and ecology. Thank you very much.